Hello, dear viewers. So let's continue with the series. Okay, so we have B3. So in an experiment to prepare a salt, a learner reacted the 3.0 grams of magnesium oxide with the 4.0 centimeter cubic of dilute nitric acid of concentration 2 moles per dm3. So this question is only limiting reagent and then the reactant nexus. So it has also some elementary items in it, like balancing the chemical equation, then also stating the symbols. Like the first question, write a balanced chemical equation for the reaction. So when you're writing the balanced chemical equation for the reaction, first of all, you need to know the acid reactions. So there are basically 4 to state, but there are many. Okay, so we need to take note of when we have acid plus a metal oxide, okay? The metal oxide, okay, what we usually gain is salt plus water. Okay, so that's what we usually gain, okay? So take note that a metal oxide is a base. Okay, so whenever it is reacting with an acid, there is salt and water that is formed. So we can go on to write the reaction based on the outcomes. So now, we look at what we are given. So we are given the metal oxide, it's magnesium oxide. We are given magnesium oxide. So the formula for magnesium oxide is MgO. That's the formula for magnesium oxide. And then with the dilute nitric acid, okay? So we have dilute nitric acid. So dilute nitric acid, the formula is given as HNO3. So this is a formula for nitric acid. So we need to know the basic acids. Like for example, you need to know nitric acid, hydrochloric acid, and then also sulfuric acid. These strong acids are commonly used in most examination papers. You need to know the symbols. Okay, so I'll make a video over it and then you'll see from. So let's try to see exactly how the salt is formed. So whenever you are forming a salt, we have to know that for a salt to be formed, a metal replaces the hydrogens of an acid. Okay, so this metal, we have our metal magnesium. The metal magnesium will replace the hydrogens of an acid. Okay, and then what will be formed is said to be magnesium nitrate. We'll have magnesium nitrate as the output. So we'll have magnesium nitrate. Now, take note that Mg forms a 2+. So Mg forming a 2+, okay, it transfers that 2+ onto the nitrate, to the ion of nitrate. So you have NO3, outside there will be a 2. So this 2 is coming from magnesium. So magnesium transfers a 2+. Then the nitrate gives a negative of 1, okay? Then plus, okay, so if magnesium replaces the hydrogens, what will happen to the oxygens? The oxygen will combine with the hydrogen that are replaced. So hydrogen and oxygen, we should have water. Now look at this. Here we have one hydrogen and then there is oxygen. But the recommendation is water should be formed. So here you have to know exactly the basic of the reaction. This is very, very important, dear viewers. You have to know the basic because this will guide you on what should be formed. Okay? So we write water here. Water should be formed. Okay? So now to make the equation balance, what we'll do, we look at things from the left side and then the right side. I hope you're able to remember how to balance the chemical equation. I usually use this method, okay? I count elements, all elements from the left side and then to that of the right side, okay? So I do this. So left, we have magnesium, Mg, and then here also we have magnesium, Mg, okay? And then also we have other elements like hydrogen here, hydrogen that side, okay? And then nitrogen there, nitrogen here, okay? And then oxygen there, oxygen there. And then we begin to check if they are equal. This side is equal to this side. The left side is equal to the right side. So we begin checking magnesium. How many magnesium? What is the mole ratio of magnesium here? Is 1. So if you're having 1 there, we can say magnesium is 1. Then to the right side, we check how many magnesiums are present. So we have 1 also. So 1 to 1, magnesium is balancing. Then we look at hydrogens. how many hydrogens are here? We can check the whole side is 1. Okay, so we can say hydrogen is 1. Also this side we check there are 2 hydrogens. So here the hydrogens are not balancing. Okay, here we have 2 and then there we have 1. So here 1 and then here 2. So what should we do? We make hydrogens this side to balance. Okay, so we follow up where there is hydrogen, we place a 2 there. So let's check where there is hydrogen. So hydrogen is here. We place a 2 on hydrogen. So when we place a 2 on hydrogen, hydrogen will balance. Okay? So hydrogen 2, hydrogen 2. And then we look at the nitrogens. How many nitrogens? So when you have a 2 in front, this 2 is for the whole compound. It's the mole ratio for the whole compound. So meaning that nitrogen is 2, hydrogen is 2, nitrogen is 2, and then oxygens, they are 6 in total. As we can see here, there is 3 and then 2 in front. So when you say 2 times 3, you get 6. Okay? So nitrogen is 2, and then this side also we have 2. And then oxygen, if you look at oxygen, this side in total, there we have 1, and then plus 2 times 3, we get 6. So here there are 3 oxygens, times 2 in front, we get 6 in total. Then here we check. Inside the brackets, we have 3. So when we say 3 times 2 is 6, plus 1 there, 7. Let me say 7. So this side 7. Let me try to clarify something here. This shouldn't be 6. Okay, so it should be 7. Okay, so here let me put a 2. So here if we look at nitrogen is let me say oxygen is 6. Okay, 2 times 3 is 6, and then plus 1 7. So 7 this side, and then this side also we check. When we say 3 times 2, we get 6, plus 1 7. Okay, so let's check if values are balancing. So these values are balancing to that of this side, meaning that the equation is balanced. Okay, so this is a simple basic I use to balance the chemical equation. Okay, so we can now write the state symbols, because the examiner is interested in writing the state symbols. Let me write again this equation. Okay, it's now dirty. Let me write it again. Okay, out of drafting. So I'll say magnesium oxide plus 2HNO 3, okay, is equal to MgO, okay, MgNO3, like that, and then we have a 2 outside, and then plus H2O. Okay, so therefore we can put the state symbols. This one is a solid, okay, and then nitric acid is in aqueous state, okay, and then this one is in aqueous state, okay, and then water is in liquid state. That way, so we have written the balanced chemical equation for the reaction. All right, so now we can come to the number of moles. Okay, so I want to also guide you on the number of moles, how to come up with a moles. So we look at the mole table. I advise this, okay, even though there are main methods of doing things, but this is the actual simple basic that you have to take note of, okay, because you can't forget the formulas in an exam. So we have here mass in grams. Okay, let me do this. We have mass in grams, okay, and then the formula for finding the number of moles, we say number of moles is equal to mass over molar mass when you have a substance of mass. And then here we have concentration and volume. So when you're calculating the number of moles, we say number of moles is equal to concentration times volume, okay, and then this side, the end part, we have gases. So if you have gases can be at RTP or STP, okay, depending, or STP. So for gases at RTP or STP, their formula is given as number of moles equal to volume over molecular volume, okay? Okay, so the molecular volume can be a standard at RTP or STP, okay? So here we can have RTP or STP. Okay, if you look at the periodic table, there is 1 mole of every gas is 24 dm3 at RTP. So that part is important. Now, let's try to see what we are given. So in here, from the question we are given, calculate the number of moles of magnesium oxide. So if we look at magnesium oxide from the data, we are given that in an experiment to prepare a salt, Elena reacted 3.0 of magnesium oxide. So magnesium oxide is having mass. So when the mass is present, then when you are trying to find the number of moles, we state number of moles equal to mass over molar mass. That's the formula that we use for that. So let's try to put up the formula from here and then we calculate. So here we'll say number of moles will be equal to mass over molar mass, which is Mr. Okay, so from here we can see what we are given. So in data collection, I will put up the data from here. We can say the mass given is 3 grams. Okay, and then what is the molar mass? So the molar mass, we can branch magnesium in this form, MgO, because we are finding magnesium oxide. So this is a formula for magnesium oxide. So we branch magnesium here and then oxygen there. So we look at the mole ratios and the number of the mole ratios from the equation. So the mole ratios here we have in 1, okay? Mg is 1, so the mole ratio is 1. Then we can state, okay? The mass number for magnesium is 24. We say 24 times 1. Okay, and then we are getting 24. Okay, and then when we say oxygen, oxygen is 1. And then the mass number is 16. 16 times 1. Okay, we are getting 16. So when we sum up these values, we are getting the net of, we are getting 40. So we are getting 40 grams per mole. That's what we are getting. So upon getting 40 grams per mole, we can now apply in the formula, okay, to find the mass. So this is our formula from here. So let's try to apply this in our formula. So we state number of moles will be equal to, N is equal to mass. The given mass is 3 grams. So we can say 3 grams there. Then over the actual molar mass, the Mr. So a Mr is 40 grams per mole. Okay. And then from there we can go on to divide, okay? We can go on to divide 3 grams divided by 40. Okay, so what you have is 0 point, let me wrap from this side so that I clear up some space, okay? So what you have is N is equal to 0.075, okay, moles. So this is what we have of MgO. So we have the moles of magnesium oxide like that. So that's what we'll get, okay? So let's look at the other question. So the other question is, find the number of moles of dilute nitric acid. So also when you're finding the number of moles of dilute nitric acid, we also see what we are given for nitric acid. So for nitric acid, we are given volume, which is 40 centimeter cubic. And then also of nitric acid, and then the concentration given is 2 moles per dm3. So this is the concentration, okay? So when we look at the combination, we have volume and then concentration. Where do we find volume and concentration? So we come to this table. So concentration and volume is found in this part of the table. So the formula for finding concentration and volume, we say number of moles equal to concentration times volume. Okay, so this is the formula that we are using. So we set up our formula here, okay, by stating number of moles is equal to concentration times the volume, like that. Okay, and then now we see exactly what we are given as concentration. So let's look at the given concentration. So the given concentration which we have in the question, we are given 2 moles per dm3. So we can go on to state in data collection. I usually do this so that we don't get lost with what we're doing. So concentration given is 2 moles per dm3. So that's the concentration given. And then the volume we are given 40 centimeter cubic. Now when you're given 40 centimeter cubic, you convert that volume into dm3. Okay, so you convert the volume into dm3 by stating 40, let me say 40 centimeter cubic, 40 centimeter cubic divided by 1000. Okay, so we use this ratio. Okay, so we usually use this ratio of 1 dm3 is equivalent to 1000 centimeter cubic, like that. Okay, so this ratio we use it for converting volume from centimeter cubic to dm3. Okay, let me write it properly. So we have 1 dm3 is equivalent to 1000 centimeter cubic. Okay, that's the ratio that we use, this ratio. So we have to be aware of it as we are converting. So here, this is what I've done so far. So I will state 40 divided by 1000. What I'll get 0.04. Okay, so that's what I'm getting. Okay, so I'm getting 0.04 as a value. Okay, so here volume will be equal to 0.04. Let me try to clear up this. Okay, so volume will be equal to 0.04. Okay, dm3. So this is the volume that I'm having. Okay, so upon having that volume, we can now look at the data, the solutions. So in solutions here, what we do, we can multiply. So let's try to put this in the solutions. Okay, so in solutions we can state, okay, in solutions we can state n will be equal to concentration. So concentration is 2 moles per dm3. Okay, and then times the volume 0.04. Okay, so we multiply with the volume. So let me just slap this. Okay, so that we clear up. So we have times 0.04 dm3. Okay, so in here we cancel dm3 and dm3 will go. Okay, and then 2 moles times this value will have number of moles will be equal to 0.08 moles. So these moles are of nitric acid. Okay, so we have found the moles in that form. That's how we find the moles. Okay, yes, and then now we look at the other question. So in here, this is where I want to talk much about, because many pupils here, they get lost on how to find the limit in reagent. Now I have to take it step by step. Okay, so this method is so easy, and it will help you to answer all types of questions regarding limiting and then the reactant in excess. First of all, I have to describe what a limiting reagent is. Okay, let me show you. Let me give you an overview. So the overview which I can give is this. Let's say, for example, you are cooking. These are reactants. Okay, this is the volume of a substance, and then now you have this. You have A and B. Okay, as the reactants. So if this reactant, if it is when it is taken into this amount of volume, okay, this reactant won't be enough to meet this volume. Okay, so this one will be limiting. Okay, and then if in a vice versa mode, for example, when you take the less amount of volume, you add in excess of the substance, then the substance will be in excess, and then the other one will be limiting. So limiting reagents and reactant in excess are reactions that are taken or are put into consideration when they are trying to see which reactant is finishing first or remaining at the end of the reaction. So we can see it in calculations. So how do we calculate, and then what steps should we take when determining the limiting reagent? So here we are just determining. Okay, now you get the two reactants. That's the first step which I usually advise. You take the two reactants of the reaction. So what are the reactants? Let's try to see. We have the reactants magnesium, and then also we have nitric acid. These are reactants. So you put them here. You put the reactants as MgO, okay, and the other one is nitric acid in this way. Okay, not the products. Products are not included in limiting reagent and the reactant in excess. Now, upon doing this, okay, the first step, you first of all put up the moles, the mole ratios. They are what we call mole ratios. So mole ratios are numbers in front of the compound or a formula. So in here, when there is no number in front there, then this is 1. Okay, we have the mole ratio of 1. So let's try to see from here. So if we have no number there, then the mole ratio is 1. And then here, what's the number in front there? Then this is 2. So our mole ratio is 1 to 2. Okay, so we can write from here, magnesium oxide is having 1, if we can see. And then what of nitric acid is having 2. So we can put up the mole ratios as 1 to 2. So let me write from here, mole ratios like that. That's the first thing that we start with. Mole ratios 1 to 2, so that you don't get confused over that. And then now we come to moles. So moles are the ones that we use for determining. We use the moles to determine, okay? So now, if you want to start with the nitric acid, if you want to see that nitric acid is a limiting reagent, what you do for the moles, you put X on it. And then now, for magnesium oxide, you put the actual moles that you have calculated. So what moles have we calculated in the equation? So we have calculated 0.075 moles. So these moles we put on the side of magnesium. So there we put 0.075. Okay, and then from here we can cross multiply. So when we say 1 times x, we get x. Okay, so I'll get x. Okay, I'll get x is equal to, when we say 2 times 0.075, what I'm yielding is 0.15. Okay, of HNO3. This is nitric acid. Okay, so we are determining nitric acid. So we are putting x on nitric acid. Okay, so this is a substance which we are determining. Okay, so this is of nitric acid. And then we go to the other one. Okay, so on the other one, we have two things that we are determining, either this one or this one. So we now come on magnesium. So I'll repeat the same things, MgO there, and then also to nitric acid, which is 2HNO3. Okay, so we have 2HNO3 like that. Okay, so we begin. So in here we put up the mole ratio. So mole ratios have to be fixed. Okay, these ones you have just to write them the way they are, 1 to 2, of course. Now we are on the side of magnesium oxide. So on the moles we put X on magnesium. Now we are on magnesium. Okay, so you put X on there, and then we look at nitric acid. What were the moles which we calculated for nitric acid? Let's try to see. The moles for nitric acid we found 0.08. So we put our moles here. Okay, 0.08. Okay, and then from there we cross multiply. So when we say 1 times 0.08, we get 0.08, and then 2 times x, we get 2x. Then which will be equal to 0.08. And then what we do here, we divide all side by 2. This side by 2, this side by 2. 2 into 2 is 1, 1 times x is x, okay? And then 2 divided by 0, it's 0, and then 2 into 0 is 0, and then 2 into 8, okay? So we're having 4. So our answer there, x will be equal to 0.04, okay, of magnesium oxide. Okay, so we are determining magnesium oxide. So remember that we had to put an x on the magnesium oxide, and then we have found the magnesium oxide. Now, after doing this, you now compare. Okay, you compare, starting from the first one here, you compare this value which we have found for nitric acid with what we have calculated so far for nitric acid. So let's compare this one and this one. Which one is bigger? Okay, so we can see that this value which we have calculated is bigger than 0.08. Okay, so this substance is requiring a lot, or it needs more of 0.15 moles to complete the reaction. Okay, so it's more like you are cooking in shima, and then, for example, meal ends on the way, or you have insufficient meal, and then from there you decide to see the quantity that can manage, or that can be more enough to complete the actual preparation of anshima. So you see what is needed. So 0.15 is what is required. So this substance is a limiting reagent, because if you compare these moles which we have calculated and then these, you find that this one is limiting. So we can say HNO3 nitric acid is a limiting reactant. Okay, we can say like that. Okay, and then this one here, looking at the for magnesium oxide, we come on magnesium oxide. What we have calculated so far is 0.04. We compare with what we have calculated. So 0.075 and 0.04. Which one is bigger? Okay, so this one is bigger, of course. 0.075 is bigger than 0.04. So this substance is a reactant in excess, because for what we have calculated is less, meaning that there is no more requirements of this substance. This substance does not require anything much. Okay, so therefore, this one is a reactant in excess. So you can say MgO is a reactant in excess. Okay, so this is how we can state it. Okay, so now if we see now, we are given in the question which one is the limiting reagent, so we can say HNO3. Are we together? So for now, please continue watching the series, okay, of more concept.